Hey everyone, welcome. I'm so glad you're here. If you're constantly looking for the absolute best, research-backed ways to really boost learning and teaching, well, you're definitely in the right place. Today we've got a fantastic explainer lined up for you. We're going to dive into a highly effective, completely free, and honestly brilliantly simple strategy that's proven to dramatically boost student math scores. So let's just jump right into it and look at this major study which was funded by the Institute of Education Sciences on something called Interleaved mathematics practice. To kick things off, let's talk about a really common scenario. Why do students absolutely ace their daily math worksheets but then completely bomb the final exam? I mean, if you're an educator or a parent or even just someone who's taken a math class, you know exactly how profoundly frustrating this is. You sit there and watch a student master a daily assignment. They're breezing through the problems, they seem to understand the formula perfectly, and boom, they get an A for the day. But then a few weeks later, when those exact same concepts pop up on a high-stakes cumulative test, it's like they've totally forgotten how to apply them. It's this universal, maddening frustration in education. Alright, part 1. The trap of traditional practice. So let's look at how these two study methods compare. On one hand, you've got your standard blocked practice. This is how practically all textbooks and worksheets are built, right? A student learns a new concept, let's say calculating parabolas, and then they're given 10 parabola problems in a row. But what actually happens here? By the second or third problem, the student just stops thinking. They go into autopilot, mindlessly plugging numbers into that exact same formula over and over again. They aren't actually practicing problem solving anymore. They're just practicing rote repetition. Now, on the flip side, we have interleaved practice. This is where you might get a median problem followed immediately by a mean problem, and then, I don't know, maybe an inequality. It's just a way more dynamic approach, and as you'll see, it totally changes the cognitive workout the student is getting. Which brings us to section 2. What exactly is interleaved practice? Put simply, interleaved practice means arranging different kinds of practice problems in a way where no two consecutive problems can be solved by the exact same strategy. I know, it sounds almost too simple, doesn't it? But this brilliantly simple little tweak completely short-circuits the trap of blocked practice. Because the problem types keep changing, kids literally can't just coast on autopilot. They are forced to actually look at the problem, analyze it, and figure out which strategy to pull from their mental toolbox to solve it. Because think about it, when kids sit down for a massive cumulative exam, the test doesn't politely say, hey, here are the parabola problems, please use the parabola formula, right? The problems are all jumbled up. On a real exam, just choosing the right strategy is half the battle. If students only ever practice using a formula when they already know it's the right one for the job, they're missing a totally crucial step. Emphasizing that choice of strategy during daily homework gives them the chance to practice exactly what they're going to need to know for the big test. Okay, section 3. Putting it to the test. So how do we know this actually works in the messy real world? Well, an incredible study led by Douglas Rower at the University of South Florida, again funded by the Institute of Education Sciences, put this to the test. And they didn't just use a handful of college volunteers in some sterile lab. No, they used a huge, robust sample of 787 7th grade math students. This spanned across 54 different classes, involving 14 different teachers in Florida public middle schools. They deliberately chose this real-world setting to make sure these results would be truly meaningful for everyday classrooms, just like yours. And just to give you a sense of who we're talking about here, let's break down those demographics. The school district was 64% white, 19% Hispanic, 8% black, and 9% Asian and other. On top of that, 53% of the sample was female, and 26% received free or reduced lunch. So this was a genuinely diverse, representative suburban school district. This really matters, right? It tells us that interleaving isn't just some niche trick for a specific type of student, it's a rock-solid strategy that applies broadly across typical diverse student populations. Now, the timeline here is where the experimental design gets really rigorous. For 4 whole months, students did their periodic practice assignments based on basic 7th grade algebra, perfectly aligned with Common Core standards. After those 4 months, they did one single review assignment and then nothing. A 1-month gap period with no specific practice at all. 1 whole month. Finally, students were hit with a 1-hour completely unannounced final test. That part is absolutely key. By making the test a surprise and spacing it a full month out from the review, researchers weren't testing short-term cramming, they were testing genuine, deep, long-term retention. But here is the absolute kicker, the secret sauce of this whole study. The researchers divided those 54 classes into an intervention group and a business-as-usual control group, but both groups saw the exact same practice problems. Let me just repeat that for a second. They did the exact same math. There were no new materials, no extra homework, No fancy special software. The literal only thing they manipulated was the scheduling order. The control group had their problems grouped by type that blocked practice. The intervention group had their problems shuffled, interleaved practice. That is literally the only difference. Which leads us to section 4, the stunning test results. Get a load of this. On that unannounced final test given a whole month after the review, the control group, the kids who did traditional blocked worksheets, scored an average of 38%. But the intervention group, the students who had their practice problems shuffled and interleaved, they scored a 61%. That is a massive 23 percentage point difference in their final scores. A 23-point jump simply from shuffling the order of the math problems on a piece of paper. Now, if you follow educational research, you know that an effect size of D equals 0.83 is practically off the charts. It's enormous. It represents a definitive, undeniable boost in student achievement. And it just proves the sheer power of interleaving. When you force students to constantly switch gears and actually choose their strategies, their long-term retention and their ability to nail cumulative exams absolutely skyrockets. Finally, section 5, interleaving in your classroom. So how do you actually use this? The beauty of this intervention is how insanely flexible and accessible it is. First off, interleaving can be rolled out in literally any mathematics course. The study looked at 7th grade algebra, sure, but the underlying cognitive principle applies across the board. Second, you can use it at home for homework or right there in the classroom. Third, it works perfectly whether you have computers or not. You do not need to beg your principal to buy some fancy new software package. You can quite literally just rearrange the problems on a printed worksheet. And finally, it aligns directly with Common Core state standards. It takes no extra funding, no giant overhaul of your curriculum, and no extra time taken away from your kids. It's just a subtle, powerful shift in how we present the work they're already doing. So I'm going to leave you with this final provocative thought. If all it takes to massively boost test scores is simply shuffling the problems around, what's stopping you from interleaving your very next assignment? The research is super clear, the implementation is 100% free, and the results speak for themselves. It really challenges the whole idea of business as usual in education and gives us this incredibly simple tool to make a profound impact. Thanks so much for hanging out with me for this explainer. Keep learning, keep questioning things, and I really hope this inspires you to completely rethink your approach to practice and mastery.